I want to be clear that this video is not intended to be a scare you away from 8GB GPUs video where we only test things out at maximum settings. I'm going to intentionally also test out reduced settings in order to give a realistic picture at what is the actual compromise of using an 8GB GPU in 2026. Specifically, I have identical 5060 Ti's here, other than one is an 8GB model and one is a 16GB model. They're both the same model from PNY on the coolers, so we can get a direct comparison, apples to apples, other than just that VRAM difference. Now, as you can see, my daughter gave me some stickers today, so enjoy. That's what's going on there. But also, as you can see, it can make a pretty dramatic difference when you're at certain graphic settings that do go beyond 8GB. So another thing that we're looking at in this video for game selection is I wanted to focus on literally in 2026. So we're looking at the biggest games released in 2026, and we'll be looking at what I think if you're building a gaming PC in 2026 with this, expensive hardware, a lot of people would be going for a 1440p monitor, but might be using upscaling in order to get decent performance there, which can actually reduce the amount of VRAM required. So again, I'm trying to target the realistic use case you might have playing new games on an 8GB GPU in 2026. Now, the biggest release so far this year is RE Requiem, and we can see here that, yeah, you can reach absolutely solid frame rates on a 5060 Ti at the max settings plus RT high using DLSS balance, which looks pretty good here, on the 1440p output. And those same settings absolutely break on an 8GB GPU. You can see that the graphics just literally don't come out correctly, in addition to the performance penalty, where we're at 75 FPS versus 47, leading to a 60% advantage for the 16GB card. But realistically, this isn't about the performance difference so much as what you're getting is locked out of using these graphics settings. That's what's happening if you're buying the 8GB GPU. Now, why I think it's really important to revisit this in 2026 is GPU pricing. The thing is that memory prices have gone insane, and that has led to the GPUs with more VRAM getting price increases, and it has also led to prioritizing specific models for supply. All signs point to the fact that NVIDIA on their 8GB cards has prioritized the 5060 Ti 8GB. It's actually sitting right around its MSRP, whereas all the other cards in their lineup have gone significantly above MSRP, some more so than others, and the 16GB 5060 Ti has been hit pretty much the worst, other than once you start getting to like 5070 Ti and 5080 and up type products. So the 16GB card, currently I'm looking at $515 for the least expensive one versus $380 on the 8GB card. It's a pretty huge price difference. Now, I should also mention that while I'm not testing it side by side in this video, AMD does offer a 16GB 9060 XT, which have not had quite the crazy price increase that we've seen on the 5060 Ti models. These are hitting about $440, and they do have roughly the same performance as a 5060 Ti, like 5% slower. And then there's the NVIDIA feature set differences and all of that. But if you are looking for a 16GB card in this price range, you might want to research the 9060 XT a little bit more. But again, the point in this video, why I'm matching the 5060 Ti against the 5060 Ti, is so that any differences that we see can be for sure because of the VRAM difference. So this is what it looks like if you load up the biggest release of 2026 and you try to play it on a 1440p display with DLSS balanced at the maximum graphics preset. This is what you get. You get a really good, very playable experience that looks great on the 16GB card, and you get a broken visual experience on the 8GB card that also doesn't have a lot of performance. You also might not even realize that the visuals are literally broken. You might actually think the lighting in the game just looks bad. but it doesn't look bad when it's working properly with enough VRAM. And again, as I was showing in that intro shot, when you're getting into like this cutscene here is where it becomes really apparent. But again, if you didn't have the side-by-side, you might think that this is what the game is supposed to look like, and just think that honestly the graphics look really bad, especially the lighting. So that's one of the issues that you run into on the 8GB cards, is sometimes it's actually unclear what's causing your problem. Now, I also wanted to look at what about trying to use native resolution on both GPUs. And if you're trying to play at the max settings plus RT high on even the 16GB card, the native resolution is a bit too much. But the DLSS balanced did look good, so I thought those were realistic settings to test. And that's the biggest thing, is when we're having the problems on the 8GB card, is it at settings that would otherwise be usable? That's a pretty big deal. The other thing I wanted to test out was this game does feature path tracing, so I did try that out. It is broken on the 8GB card, and the performance is terrible. But as you can see on the right-hand side, it's not like the 5060 Ti 16GB is getting an amazing path tracing experience here. This is with balanced DLSS. You could go down to performance mode, pick up a little more performance, and then maybe use frame gen. So in a single-player game, I know there are some people who would make that choice, but I think overall, I'd probably steer clear of the path traced settings on the 5060 Ti. But once again, that's what it looks like side by side in that scene. The lighting is just completely broken on the 8GB card, in addition to the issue with just overall performance being low. But this is what I mean about this video is not intended to just be a scare video flaming 8GB cards. I really want to talk about the actual trade-offs that you're getting. So if you just switch down to the normal graphics preset, essentially medium, but that's what this game calls it, and turn the ray tracing off, and play at 1440p native resolution, both GPUs do absolutely fine. We see a 2% performance difference, but I don't see signs that that's probably causing issues with the graphics or anything like that. So it seems like a good experience on both GPUs here, and you could go ahead and turn on balanced DLSS on top of these reduced settings, and now we're getting 110 FPS versus 108 FPS. It's just overall like a high refresh rate experience on both cards. So what I really want to look at then is this. So when you're buying the 8GB card instead of the 16GB card, what does that mean? What it really means is you would be playing at different settings than the 16GB card. So this is more like what the difference in experience might be. On the 16GB card, I might go with the max settings RT high with DLSS balanced, whereas on the 8GB card, I might go with the normal settings RT off and DLSS balanced. And yeah, it looks a little better on the right-hand side, but it's not like the left-hand side actually looks that much worse or anything like that. So, it's nice to have the increased visual fidelity, but I'm not trying to say that you just can't play games on the 8GB card. Now, another huge release for 2026 is Forza Horizon 6, and at its maximum settings, which is called Extreme Plus RT, and again, using DLSS balanced on the 1440p output, once again, the 16GB card, it does great, completely usable settings. A lot of people might want to have this be how you play the game. Averages 70 FPS in the built-in benchmark, which is very reflective of the actual performance throughout most of the game. And the 8GB card is sitting down at 38 FPS and has some stutters if you look at the frame time graph. So, stuttery low frame rate on the 8GB card, smooth frame time graph, higher frame rate, very good for a racing game on the 16GB card. So that is, again, the difference. On the 16GB card, you can absolutely play at the maximum graphics preset, maybe relying on a bit of upscaling, which is looking really good these days, and have a very good experience. Now, I did also want to test out what if you were trying to play at the max settings without upscaling, and then once again, it's a bit much for even the 16GB card, where it's averaging 45 FPS. Now, the 8GB card's only averaging 27, so it's a 67% advantage for the 16GB card here, but probably not the settings I would use on the 16GB card. But as I showed you at the beginning, using DLSS balanced on the 1440p output on the 16GB card does enable the maximum settings. You could Absolutely use those settings. Balanced DLSS on the newer DLSS models does look pretty good on the 1440p output. So these are realistic settings that are being compromised by the 8GB card. Now, if I notch back the graphic settings considerably. By the way, the graphic settings in this game, so Extreme plus RT is the highest graphics preset in this game. The next one down is Ultra plus RT, and the next one down is High plus RT. The next one down after that is just Extreme that doesn't have the RT. So while this is called the Extreme preset, and you actually count the number of graphic settings, this is more like a medium graphics setting, just to be clear. So what we're looking at here, the 1440p Extreme native resolution, is effectively a middle graphics preset when you're just looking through the presets. Anyway, we're getting 81 FPS on the 16GB card at native 1440p. And the 8GB card is actually doing pretty well at 63. Now, the frame time graph is just a little bit spiky. Not too bad. You could use it. So this is one of the games where instead of getting the graphics to break, it just kind of seems to run slower. So different game engines handle running out of VRAM differently. But again, we're already like 3 or 4 notches down on the graphics presets, and we're still seeing problems on the 8GB card compared to the 16GB card, although it is now pretty usable despite a few little blips on the frame time graph being just a little bit stuttery. Now, if we go ahead and kick on the balance level upscaling, on the Extreme preset, so the same preset, but now we're using the balanced upscale, we're now getting 102 FPS on the 16GB card and 73 FPS on the 8GB card. And the 8GB card is still seeing a few little blips on the frame time graph, whereas the frame time graph is looking just perfectly buttery smooth on the 16GB card. By the way, I've heard a lot of people complaining about stutters in this game, and while the open world can be stuttery even when there isn't any VRAM issue, it is more stuttery if you're going over your VRAM capacity. So I think some people may be experiencing stutters due to VRAM issues and may be unaware that that's what's happening in this game. Anyway, so this is absolutely playable on both. And the stutters are pretty infrequent and not that big on the 8GB card, so you might actually use those settings, or you could turn it down even more. But you can see this is a game where even several notches down on the graphics presets, you're still experiencing 8GB VRAM problems. So one way you might actually play this game is on the 16GB card. You might be on the maximum preset Extreme plus RT at DLSS balanced and be averaging around 70 FPS. On the 8GB card, you might play at the Extreme preset, but with RT completely turned off and using DLSS balanced, and then you'd also be around 70 FPS. Now, the built-in benchmark is not good at highlighting the graphical differences of ray tracing in this game. So I'll say that if you're looking at the two sides and you're like, they look the same, I'll say that in some scenes like this one, there's not a huge difference with ray tracing in this game, but there are definitely some scenes where the ray tracing actually does make a pretty big difference in the visuals. So just keep that in mind. So again, though, I'm not trying to scare you off. This is not a fear-mongering video. I'm just trying to show, like, if you buy the 8GB card, you will have to turn down certain settings to get a good experience. And in some scenes in this game, you're mostly just losing the ray tracing, which in some scenes makes a pretty big difference, others it doesn't. Another big release from this year is Pragmata. At 1440p on its maximum graphics preset, although path tracing could be turned on individually, and I'm not doing that on this test. I will show you that in a minute. The quality preset is the name of the highest preset here, and it does include ray tracing. By the way, this is native 1440p. I'm not saying quality upscaling is being used. I'm saying it's native 1440p. And watch what happens to the visuals right now. Look at the left-hand side of the screen. The graphics are broken again. But again, you might not realize that if you were just playing the game on the 8GB card. Because yeah, there's a few little stutters on the frame time graph, but you might just think it's a slightly stuttery game with bad lighting. But in reality, it's actually a much smoother frame time graph if you have enough VRAM, and the lighting's not broken and looks a lot better. So the overall performance, if you just look at the average frame rate, is pretty much the same, but the graphics are broken at times on the 8GB card, and the frame rates are high enough that those were absolutely usable settings. We're not looking at unrealistic settings just to find it spilling over the VRAM. Now, If you use balanced level upscaling, again, sometimes upscaling can reduce how much VRAM is being used. And that's what we're looking at here. Now, performance goes up. It's now 105 FPS versus 104. Again, the frame rates seem about the same. And right now you might be like, okay, the visuals are looking about the same between the two. But once again, when we reach this more open area as we turn into this tunnel, the graphics completely break on the 8GB card again. And there was a big stutter as we transitioned into the new zone on that card when there was not on the 16GB card. So once again, even using upscaling, we are seeing the 8GB card be more stuttery and with broken visuals, but again, it's performing well enough that somebody who bought that card might not realize that the problem is their card. They might just think the lighting looks bad and that the game's kind of stuttery, and once again, that's one of the problems that you can run into on 8GB cards. Now, because the performance was so high at the maximum preset, I did try enabling path tracing just to see if there was enough headroom for it. Now, at balanced DLSS, the path tracing is like 50 FPS or so when you're in the more closed-in environments, and it drops into the lower 40s when you're in the more open environments. So it's not an amazing experience. You could go down to the performance mode upscaling, which is a little more aggressive than I'd like to go, to get a little more headroom than maybe use some frame gen. So it's not completely out of the realm of somebody using it, but again, it breaks on the 8GB card, even though the performance numbers are actually higher on the 8GB card. By the way, that's one thing that's really important to look out for, is when you're just looking at benchmark graphs, you might not realize the 8GB card is broken like it is here. Because in this case, the 8GB card is faster than the 16GB card by 9%. Whenever you see a significant performance advantage for the 8GB card over the 16GB one, assume the graphics are broken if you're looking at a bar chart. Anyway, so what if we kick down the preset though? So if we go to the balanced preset, which again is more like a medium preset, but the game just kind of uses unusual naming schemes. Also keep in mind that this is native resolution. I'm not using balanced upscaling. It's just the name of the graphics preset is called balanced. And the balanced preset does not include ray tracing. In this case, now the GPUs are getting about the same performance. They're in the mid to low 90s. And there's a little bit more of a frame time spike on the 8GB card as we rounded that corner. And we can see that the 16GB card is allocating more than 8GB of VRAM. And that probably did contribute to that little spike as you load it into the new zone. But overall, the 8GB card, the graphics don't look completely broken, and the performance is pretty similar. The frame time graph isn't quite as smooth though. And this is on basically a medium type preset that we're looking at here. But it's overall a pretty good experience. Now, so what does that mean? So how might you actually play this game if you bought the 8GB card versus buying the 16GB card? Well, on the 8GB card, you'd probably be at the balanced preset, and you're getting a nice high frame rate, and everything's pretty good. You occasionally get a little bit more of a stutter as you load into a new zone. Whereas on the 16GB card, we can be at the quality preset, which includes ray tracing, which gets you, some additional graphical features here. And as we load this new zone, again, frame time spike on one side and not on the other. Also, there are definitely some visual differences between these presets. For example, you get a bunch of reflections and lighting on this metal here that you're not getting here. And things like that. So while the graphics look fine on the balanced preset, there's definitely a trade-off happening, right? But I mean, the game looks fine on the balanced preset. It looks completely okay, right? So you can absolutely still enjoy the game at a nice high frame rate, and you just take a little visual hit to the kinds of settings that you're gonna be using, and that's that. But the first three games, big games that I've tested of 2026 here, all had pretty big issues on 8GB cards, at least at certain presets. However, that's not true of every big game released in 2026. Crimson Desert is another one of the biggest releases of 2026, and its maximum settings don't run any faster on my 16GB card, and there's really only about 7GB of VRAM being allocated here. But even using DLSS balanced, neither GPU has really the performance for the maximum settings in this game. If you turn ray reconstruction or ray regeneration on in this game, it kicks on a hidden higher ray tracing mode, which is incredibly demanding. Now, if we just drop down to the Ultra preset, both GPUs average pretty close to 60 FPS in this intro scene, By the way, this intro scene is very demanding. Lots of foliage, lots of player characters, lots of lighting happening, things like that. A lot of parts of the game perform a lot higher. Anyway, native 1440p Ultra, both GPUs are doing fine. Close to, but not quite 60 FPS average. Frame time graphs both look smooth. I'm not seeing any visual differences. No sign that we're allocating over 8 gigabytes of VRAM. So this appears to be a game that runs absolutely fine on the 8 gigabyte card. I also tested it out with balanced level DLSS on the Ultra preset, and now you're getting 70 FPS matched on both GPUs. Although, to be honest, this is a game where I personally wouldn't use upscaling. I would just turn down the graphic settings at native resolution until I hit my desired frame rate. Because if you look at things like the grass right here, I just really think a lot of the foliage and grass and fire effects and things just look bad with upscaling in this game. That's just kind of a side note. But as far as 8 gigabytes versus 16 gigabytes, Crimson Desert completely fine on the 8 gigabyte card, no matter what graphic settings I was testing out. Another huge release of this year is Subnautica 2. Now, it's technically still in early access, not fully released, but given that there's hundreds of thousands of concurrent players, this is definitely a game that people are buying and playing on their graphics cards. So completely fair to test out. And it is Unreal Engine 5. And say what you want about Unreal Engine 5, it's actually very efficient with VRAM usage. The Epic settings here are not going over 8 gigabytes of VRAM, and the cards have pretty much the same performance. But that performance is low because this is Epic settings at native 1440p in an Unreal Engine 5 game. That being said, if you kick on DLSS balanced on the Epic preset, you're actually close to a 60 FPS average on both cards, but once again, there's no sign of any advantage for the card having more than 8 gigabytes of VRAM, because again, unless the game is needing more than 8 gigabytes of VRAM, there is no advantage to having it. It doesn't just increase your performance in games, it only helps, or really you should think of it as having more VRAM doesn't really help. It's just that if you don't have enough, the game just kind of breaks. That's what happens, right? Now, if you play at the medium settings, both GPUs are good for well over 60 FPS at native 1440p resolution. If you go ahead and kick on a balanced level upscaling on top of the medium preset, both GPUs are good for well over 100 frames per second. And that's what I've tested out for this video because, again, this video is specifically about games of 2026. So while I could have tested out tons of older games, I'm looking at the biggest releases of 2026. So how should we summarize the experience? In 3 out of the 5, or if you want to think of it as 60% of the biggest releases of 2026, there are graphical presets that work completely fine on this class of hardware, as long as you have enough VRAM, but they break on the 8 gigabyte card. So it is absolutely true when people complain about putting 8 gigabytes on a card of this performance level. A card of this performance level can absolutely handle graphics that use more than 8 gigabytes of VRAM and hit high frame rates that a person very well might use. And we saw that in 3 of the 5 biggest releases of the first half of 2026. However, in every single one of them, you can just find some graphic settings that work just fine on the 8 gigabyte card. And I think that that's really important when we do this kind of discussion, because if you just focus on the negatives, I think you're not giving an accurate information to people. So you can play any game released in 2026 on an 8 gigabyte graphics card at graphic settings that look fine and at frame rates that are absolutely satisfactory. But you are very, very likely to have problems if you just kick on the maximum preset, kick on some upscaling, and on the 16 gigabyte card you're fine, and on the 8 gigabyte card you're struggling. Also, like I said, you are sometimes having trouble identifying that that's even happening, right? Where in certain games, like when I was looking at Pragmata, we saw that there were graphic settings that actually seemed like they were fine. The frame rate was actually good, right? So you have a good frame rate, The game's a little stuttery, but not much, so you don't even realize the game's broken, because if you don't have this side by side to compare what it's supposed to look like, you just think the game has terrible lighting and things like that. This can also happen with textures. I didn't see it in these particular games I was testing, but in some games, you just think the textures look terrible, but really it's just not loading in the higher resolution textures because you don't have enough VRAM. So these are all the headaches that come along with these with buying the lower VRAM card. I think it's also, in fairness, important to note that if what you mainly do with your PC is play competitive online games, oftentimes those work fine at their maximum settings, or even if they don't, oftentimes you wouldn't be using their maximum settings for competitive advantage. So like in a game like Call of Duty, yeah, the maximum settings are absolutely going over 8 gigabytes and causing problems. However, most people playing a competitive game are going to turn down graphic settings to improve visibility and improve frame rates. So in that sense, what's my actual take on, you're looking at the graphics card market and you're like, should I really spend that much more, or should I just get the 8 gigabyte card? I mean, I'm trying to just give you the honest answer. The 8 gigabyte card has problems, and those problems are getting more and more common. But every game can still be played on them. You're just gonna have to put in the work to find the settings that are best for your card. And sometimes that will come with a visual trade-off, and you're gonna have to figure out what's going on if things aren't looking right in your game. If you're mostly playing competitive online games, honestly, probably not a big deal. You know, if you do have to pick a card with more than 8 gigabytes of VRAM, I did mention that if you're buying in the new market, the 9060 XT 16 gigabyte version at $440 is a lot easier to stomach than the 5060 Ti at $515. It's not that much more than that $380, 5060 Ti. So look, I can't in good conscience recommend anybody buy an 8 gigabyte GPU in 2026. Games are just simply not designed around that VRAM capacity anymore. But they all offer scalability that will work. So if it's just not in your budget to go above that, then do what you gotta do, especially if you're more into the competitive gaming side of things and all that. I'm just trying to give you the real experience of what it's like in 2026 on an 8 gigabyte card, since VRAM prices have gone through the roof. Hope you guys found the video useful and or interesting, and you have an excellent day.